Hello, Christoph here. In this demo, I am going to show you how you can verify and test event-driven applications, both on your local machine and running in a cloud provider like Kubernetes or OpenShift. So the application here is our system under test. I prepared this little Quarkus application. It's a food market application. And this application listens for incoming events of type booking and supply. So booking sources, whatever this will be, can produce a booking, which is a very simple JSON object with a product amount and a price. And at the same time, the supply sources can fire supply events, also giving a product the amount and a price. And the food market application will then try to match bookings and supplies. And once the booking and supply is matching to certain criteria, then the application will create booking completed events and shipping events. Also, the application provides a REST API so that you can go there and also have this create, read, update operations with REST API. And it's also providing a small web UI so you can see all the bookings and supplies. So every state is held in a database. It's a Postgres database. So this is the demo we want to test. And first of all, let's start the Quarkus application. I'm using the Quarkus dev mode, and Quarkus will automatically start test containers for me regarding the Postgres database and the Kafka message broker. So this is running now on my local host, and also the test containers should be running. So then I can go to the browser and open the little web UI. It's very, very simple, and you can also create like booking. Let's say here we want to have 10, and the price is like this, and it should be pending. So creates this booking, and if we create a matching supply for the same product and some amount and a price that also matches, then we should be receiving both. And now this has been completed. The booking has been completed, and the supply is in status sold because all the complete amount is sold right now. So this is what it looked like, and now I want to write an automated test for the REST API. Let's start with this. And the framework that I'm going to show you is called YAKS, and YAKS is using behavior-driven development. So this is a Cucumber feature file. It uses the normal given, when, then syntax and provides predefined steps that you can use to, for instance, send out an HTTP request. So I want to test the REST API of the application. I give the endpoint URL, which is on the one hand a environment variable. We use this later on when we execute the test in a Kubernetes environment. Or if this is not set, then it falls back to localhost, which is the local development. And then a little health check, and let's create a booking. We want to send an HTTP request. We give a JSON body, set the content type, and then we send this post request to /API bookings, which is the REST API. And then we are able to also verify the HTTP response. We first check that the returned status code is 201 created. And we can verify the response body, which is the JSON of the booking that has been created in the database. So we also receive this ID, which comes from the database sequence, and we can save this for later reference in a variable, which is called booking ID. And we will use this in the later steps in the test to verify the booking status. And the other fields will just be compared. So YAKS and the underlying framework Citrus is providing a very powerful JSON validation mechanism, so that you can give an expected template here, and then YAKS and Citrus will just make sure that everything is as expected. We can also ignore some fields, and we can do a lot of powerful things in this validation. So now the booking has been created. Let's create also a matching supply, the same HTTP request body. And now we send this post request to /API supplies. And we just receive the status code 201 created. And then as these match, we should wait some time and then verify the booking completed state. Here we reference the booking ID that has been saved in the very first step. And then we can just get the booking status and match this to be completed. And that's the end of our test. So if you want to test this, you can run this test on your local machine using a YAKS run. And then you give this feature file, and that's everything that YAKS needs. I'm just using this -- local because I want to execute this test on a local host. I'm also connected to an OpenShift cluster in this terminal, so I make sure that this test is not run against the OpenShift cluster, but on my local host. So I say YAKS run -- local, and now the HTTP requests were sent and the responses validated. So let's have a look into the browser, and if I refresh now, I see that this has been created, and the supply has also been created, and now the booking is also completed, and the supply is sold. Good. So let's at one state you might be happy with your local development, and now you want to run the same test also against a running application in the cloud, and you can do this with YAKS very easily. So I have an OpenShift cluster here. This is the Quarkus application. It's already deployed. It's the very same application that I was running locally. And I also have this Postgres database and the Strimzi Kafka cluster already prepared in this namespace. I can open the UI. This is the UI, and there's already some bookings and supplies here. And now I want to run the same test that I was running locally. I want to run inside of the OpenShift. And this is possible with a operator. So if I have a look into the installed operators, here's the YAKS operator, and this is the connection that makes it happen that the test is able to run also inside of the OpenShift cluster. So I just put the logic of the test, the feature file, to the operator, create a custom resource on the cluster, and then the operator will create the runtime and execute the test. This is the Strimzi operator, and I also have CamelK installed that we will be using later on. So let's switch back to the topology view, and now I'm not using the -- local anymore, but I'm giving some environment variables because right now I need to connect to the Strimzi Kafka cluster in my namespace, and I need to connect to the REST API of the food market application that is deployed in the user namespace. So if I run this, now the test should be created in the OpenShift. Here it is. The YAKS operator creates the runtime, and if all goes well, it should be also reported as a successful test. So this is a job that is executed, and there's a pod that runs the complete runtime, the YAKS runtime. So let's see, this is turning green. We can also have a look into the log files of the test, and yeah, this test has successfully completed. So let's move on and have a look into OpenAPI, because this is also a very important concept. And YAKS is also able to connect with OpenAPI. So the food market application exposes an OpenAPI specification. It is this one here. So this is an arbitrary OpenAPI specification, and every possible REST operation is documented here. So we have some here on /bookings, we have a GET request, and we have this POST request, which is the operation ID add booking for adding bookings, and we have the schemas of the JSON structures here with the booking and the properties and so on. So everything like the rules and the specification is in this open API. And YAKS can load this specification, so it loads the specification directly from the running application using the Quarkus open API endpoint. And once this is loaded, then we can do something like when invoke operation add booking, and this references the operation ID, and we say then verify operation results 201 created. And in the background, YAKS will create a proper booking based on the specifications and based on the schemas that we have in the specification. So there will be a valid booking sent in the post request to the server. And the results will also be checked that the results in terms of the headers and the response body is as expected according to the open API specification. And we can also, override some variables, like here we set the ID of the booking to 0, and then we say get booking by ID, and we expect a 404 not found. And this also works for supplies, so we can invoke the operation add supply. And as I already mentioned, in the background, all the response bodies and the request bodies will be generated from the open API specification. To be able to have some more human readable values, I can say, please, the product should be a random enum value out of mango, peach, and banana. And the amount should only have 2 from 0 to 99. And the price should also be human readable. So I can control a bit the auto generation of the fields that are generated from the open API specification. Yeah, and if I run this test, let's maybe run this first of all locally. This is the open API feature -- local. And this is a great concept because you can verify your local application, and the turnaround is very fast, and you can also develop your test so that you are happy with your test. And once you're happy with your test, then you can start also running this on the OpenShift. So this ran on my local host. If I go to the local host 8080, I should see here some generated client and some generated bookings and so on from this open API specification test. Okay, so let's move on and also test the eventing part. So the application also listens for Kafka events. So in this YAKS test here, I'm creating a Kafka connection. I'm connecting to the Bootstrap server, which is set to a value in the OpenShift cluster, or falls back to localhost for the local testing. And I'm giving a topic, and then I can really mix all these different steps. I can first of all create a booking and a supply with HTTP, and then I expect a Kafka message with this body, and this should be a shipping event that is created out of the matching supply and the booking. So I can really have both in the same test, like having HTTP requests, having Kafka event consumers, and of course verify the JSON body. I can also send bookings with Kafka, so I send a Kafka message on the topic bookings with this JSON body, and then I send the supply with this JSON body using the Kafka connection. And again, I'm expecting a shipping event because these two match, and then I'm expecting this shipping event. So let's also run this test. This is the eventing. It's 0.5 food market eventing minus local. So this should also be running okay, because Quarkus has also started the Kafka message broker on my local host with test containers. So the test is happy. That's great. So maybe let's see also a failing test. So if I go in here and in this shipping event, I'm maybe here saying the client is client foo, but obviously it's client Kafka that is sent in. So if I rerun the test, I should be provided with a validation error, because one of the fields in the JSON is not as expected. So let's see if this is working. Okay, we received an error, and the error was that the value for the client is not as expected client foo, and it was client Kafka. So this one is failing okay. Okay, let's move on. Let's fix the test again, and let's move on to some other things that you can do. For instance, testing the user interface. So we have already seen the browser that can create some bookings with the HTML forms here. So we can also run some UI tests with the YAKS. Let's see how this works. So we can start the browser, and the browser is using a type like Firefox, Chrome, HTML unit, and so on. And then we navigate to the homepage URL, and we check that there's a heading with the food market demo, and then we submit a form, create a booking, navigating to the home URL, selecting the option on the select drop down, setting some user entrance text fields for the input field, and so on. And at the very end, we just click the button with the ID save. So let's just run the test locally and see how this goes. This is the UI part, and minus local, and it should start my Chrome. And I also added some sleeping so that we can actually see something happening. So this is a arbitrary Selenium test that runs now on my local host and is okay. But the good thing is I can also start this and just execute the very same test in the OpenShift cluster. So now I remove the minus local, and I give the connectivity environment variables. And if I run this, then I should be provided with a second test here. And the good thing is that we can also run this UI specific tests on Kubernetes. So this is connecting to Node VNC, and we should shortly see the browser starting and executing the same test on the OpenShift, if this is working. See? Yeah. Now the browser starts, and we just receive the same test as we have seen locally, which is great. So this one is okay. The test should be green. Yes. So that's the concept of YAKS, that you can develop your tests locally, you can verify everything locally, but also at the same time be able to run this with the YAKS operator on the target platform, which is a Kubernetes or OpenShift platform. Last not least, let's go and have some fun with cloud services. So in this scenario, I'm using an AWS S3 service, I'm connecting this to a CamelK pipe, and this CamelK pipe will translate the events from S3 to Kafka, and then the food market application will just receive these events and send out completed events. And YAKS as a framework is able to also start the test container for AWS S3, which is a local stack container on the local host and in the OpenShift platform. So let's see how this works. Let's have a look into the test. So first of all, we enable some service S3, then we start the local stack container. This is from test containers. And then we create some camel specifics because we want to send in some AWS S3 event with camel. We load the pipe. This is the CamelK pipe for translating the events to Kafka or HTTP. This is the pipe, the CamelK pipe. It starts with an AWS S3 source, gives all the connectivity parameters, secret keys, and so on. These are the test containers generated stuff. And then we do some inserting of headers, and we log something so that we can see something. And then we just bind this to the HTTP endpoint /API bookings. So every time a user creates a file in the AWS S3 bucket, it should be automatically bound to the HTTP endpoint URL of the food market application. And we will also test this by sending in some AWS S3 file. This is the content of the file. And then we just see that everything is hopefully working. Let's run this test locally. Run. This is cloud service --local. So this will start the local stack container. It will also start the CamelK integration, all on the local host. And then it fires some S3 bucket event, and CamelK, the pipe, should invoke the food market application REST API. And then everything is reporting okay. So this is the CamelK integration that has been started, and the local stack container has also been started on my local host. And once again, if I'm happy with my local environment, I can just remove this --local and also run this on my OpenShift cluster. And then I should be provided with another test. And this should then also create a local stack, which is the test container that simulates the AWS S3 source. So let's wait for it. This is the container, the local stack container. And it also should start the CamelK integration. We're waiting for this. This is why I was also installing the CamelK operator in this cluster, because now the pipe is generated the runtime from the CamelK operator. This is the CamelK pipe. And now the same test is able to run and create the booking with AWS S3. This is reporting green, and we can have a look into the UI and see that here the browser supplier, and that this is as expected. So very, very good. We have seen a lot of different tests with YAKS, and this completes the demo. If you have questions, please reach out, and thanks for watching.